Today we start our chapter on trig, and we're going to do that by talking about ratios. Remember when we talked about similar triangles? We had that corresponding sides had a constant ratio and corresponding angles were equal. We also talked about the side C being called the hypotenuse. We want to also give names to sides A and B. Looking at angle theta, B is called the opposite because it is directly across from the angle. Again, looking from angle theta, A is called the adjacent because it is beside the angle. In the triangles below, angles C, F, and I are corresponding and therefore equal. We're going to compare the values of the opposite over the adjacent in each of the triangles. In the first triangle, I have the opposite 3 over the adjacent 4, so I have this fraction 3 over 4. In the second triangle, the opposite is 6 and the adjacent is 8. Notice 6 over 8 can reduce to 3 over 4. In our final triangle, the opposite is 9, the adjacent is 12, and that reduces to 3 over 4. So what we can see here is that when I have equal angles, no matter what the value of the sides are, when I make these ratios of the opposite over the adjacent, they're all going to reduce to the same value. This shows that there's a constant ratio of sides for an angle. This means that if we know the measure of an angle, then we know what the ratio of the sides of the angle will be. It also says if we know the ratio of the sides, then we can figure out the measure of the angle. That's a lot of information that we will spend time working on throughout this chapter. So let's begin by looking at 3 names of ratios of sides. We will have sine, cosine, and tangent. We have abbreviations for each of them. Sine, we abbreviate as SIN. Cosine, we abbreviate as COS. And tangent abbreviates to TAN. In this case, I want you to look at the triangle ABC, and I want you to look at the angle theta. I'm going to make all of the ratios off of theta. Sine is the opposite over the hypotenuse. For short, I'm going to write O over H. Cosine is the adjacent over the hypotenuse, which is A over H. And finally, tangent is the opposite over the adjacent, which is O over A. As much as I don't always push for memorization, it is really good to be familiar with sine, cosine, and tangent because I'm going to use them a lot and I probably will say them quickly. So it's a good idea to have these, to write them down, maybe write them down a few times until you really feel comfortable with sine being opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent is opposite over adjacent. The more familiar you are with them, the better this chapter will go. In this example, I have 5, 12, and 13. When I look at theta, sine of theta is the opposite 12 over the hypotenuse 13. The cosine of theta is the adjacent 5 over the hypotenuse 13. And then finally, the tangent of theta is the opposite 12 over the adjacent 5. We're going to do this again, but notice I move theta to be at the top of my chart. Now the sine of theta is the opposite 5 over the hypotenuse 13. The cosine of theta will be the adjacent 12 over the hypotenuse 13. And the tangent of theta will be the opposite 5 over the adjacent 12. So as we look at the triangles, it's important to identify where our angle is at before we determine what the ratios are going to be. In this figure, I have 2 angles, A and B, and we are going to find a bunch of ratios based on this triangle. So we're going to start with the sine of A. So I'm looking at A. The opposite is 15. The hypotenuse is 17. I'm leaving my answers as fractions. I won't be putting these in my calculator to get a decimal. The cosine, I look at A, adjacent is 8. The hypotenuse is still 17. Moving on to B, I'm asked for tangent. So tangent is opposite, which is 8, over the adjacent, which is 15. And the last one says the sine of B. So that's the opposite 8 over the hypotenuse 17. Let's do that again. This time I've changed the sides. I have the square root of 3 times 3, I have 3, and I have 6. And I want to find the sine, the cosine, and the tangent of A. So starting with the sine, the opposite is 3 square root of 3 over the hypotenuse of 6. The 3 on the outside of the radical and the 6 can reduce to become the square root of 3 over 2. For the cosine, I look at the adjacent. For the cosine, I look at the adjacent 3 over the hypotenuse 6. Again, I want to reduce. This is 1/2. And the last one says let's do the tangent of A. So that's the opposite, 3 square root of 3, over the adjacent 3, which gives me the square root of 3. We have 3 more ratios that we want to talk about. We have secant, cosecant, and cotangent. Secant is abbreviated SEC and is equal to 1 over cosine, which is h over a. Cosecant we've abbreviated as CSC, and it's 1 over sine, which is h over o. And then cotangent, abbreviated COT, is 1 over tangent, which is the adjacent over the opposite. I will say when I look at them, I always remember them as what they're the inverse of. So I will use that secant is 1 over cosine, cosecant is 1 over sine, and cotangent is 1 over tangent. Really what that will do is it'll just give me the inverse. I will flip over the ratio so that I'm not having to think h over a, h over o, or a over o. I'll just flip over whatever fraction I have to get the secant, cosecant, and cotangent. Let me show you what that looks like. So I have this triangle that's 7, 24, and 25, and we're starting with, let's find the cosine of B. B, adjacent is 7, the hypotenuse is 25. We just said that cosine is related to secant because secant is 1 over cosine. So if I flip it over, that gives me 25 over 7. If I look at the tangent of B, that's the opposite, 24 over the adjacent 7. Cotangent will be 1 over tangent, which means I will switch this over to 7 over 24. The sine of B says the opposite, 24 over the hypotenuse, 25. And the relationship between sine and cosecant is 1 over sine. So flipping 24 over 25 becomes 25 over 24. In this triangle, I have 21, 20, and I have an angle A. This is a right triangle, which I will indicate by putting the little square on the corner. And I want to find sine, cosine, tangent, secant, cosecant, and cotangent of A. The first thing I need to do is find the missing side. That says, let's call it x, and we're going to use the Pythagorean Theorem. I have 21 squared plus 20 squared gives me x squared. So I grab my calculator, 21 squared plus 20 squared is equal to 841. And then I'm going to take the square root. The square root of 841 is 29. Now that I have all 3 sides, I'm ready to find the ratios. Sine of A is the opposite, 21, over the hypotenuse, 29. Cosine of A is the adjacent, 20, over the hypotenuse, 29. And tangent of A is the opposite, which is 21, over the adjacent, 20. Then I want the secant, the cosecant, and the cotangent of A. So to get the secant, I remember it's 1 over cosine. So 20 over 29 changes to 29 over 20. Cosecant of A, I'm going to flip sine over. I have 29 over 21. Cotangent of A, I'm going to flip 21 over 20 to get 20 over 21. A line or a ray that goes through the origin forms an angle with the x-axis called the terminal side. Notice that I can give you a point xy on that line or ray to indicate the angle we're talking about. Then this gives me a horizontal distance x, a vertical distance y, and we can find the hypotenuse that corresponds to x and y. Let's take an example where I have the point 4855. The horizontal distance is 48, the vertical distance is 55, so we want to take time to find the measure of the hypotenuse. To find the value of the hypotenuse, we are going to square 48 and square 55, and then that'll give us this value r squared. I'm calling it r because the picture has r on the hypotenuse. 48 squared plus 55 squared gives me a value of 5,329. I'm going to take the square root of that, and that tells me r is 73. Now that I have the value that r is 73, x is 48, and y is 55, we could find the sine, cosine, and tangent of theta. The sine of theta is the opposite, 55, over the hypotenuse, 73. The cosine would be the adjacent, 48, over the hypotenuse of 73. And the tangent would be the opposite, 55, over the adjacent, 48. Let's find the values of the trig functions of the angle in standard position whose terminal side passes through the given point, 6, 6. So what does this say? This says that we have a triangle. The point at the top is 6, 6. My horizontal distance would be 6. My vertical distance would be 6. And I first need to start by finding my hypotenuse, x. Just like the last figure, we'll add 6 squared and 6 squared to get x squared. 6 squared and 6 squared is 72. When I take the square root, I get that 72 is really 36 times 2. So the square root of 36 is 6. I have 6 squared of 2 is x. So this is my value of x. Now that I have my values of 6, 6, and 6 square root of 2, I'm ready to find the sine, cosine, tangent, cosecant, secant, and tangent. For the sine, I have the opposite, 6 over 6 square root of 2. We can reduce that to 1 over the square root of 2. For the cosine, I have the adjacent, which is also 6 over 6 square root of 2, which reduces to 1 over the square root of 2. Tangent, opposite, is 6. Adjacent is also 6. 6 over 6 is 1. Then cosecant, secant, and tangent, we will look at our previous ratios to find the answer. For cosecant, I'm going to look at sine, which says I have the square root of 2 over 1. I can reduce that to square root of 2. Secant, related to cosine, I flip to get the square root of 2 over 1 again, square root of 2. Tangent, I had 1, so cotangent is also 1. Finally, given the sine of theta is 12 over 37, we're going to find the cosine and the tangent of theta. Now, even though this is presented differently, I still want you to think about a triangle. So in my triangle, I'm going to label an angle as theta, and it says the sine of theta is 12 over 37. That means the opposite is 12, the adjacent is 37, and I'm missing a side, we'll call it x. Once again, we'll be using the Pythagorean Theorem, which says x squared plus 12 squared is 37 squared. 12 squared is 144. 37 squared is 1,369. If I subtract 144, this gives me that x squared is 1,225. We can take the square root to get that x is 35. Now that I can see all three sides of my triangle, I'm ready to figure out the cosine of theta and the tangent of theta. The cosine of theta says to take the adjacent, which is 35, divide by the hypotenuse, 37, and then the tangent of theta is the opposite, 12, over the adjacent, 35.